Great. Hi there again. Scott from EdgeMath. I've got some counting problems a student asked about the other day. So combinatorics questions. Let's load them up here. So we've got a case where there's 7 men and 5 women on a city council, and we need to select 3 of those to serve on an executive committee. So we can answer a few questions about that. So how many ways are there to choose an executive committee, just in general? How many ways are there to choose one if it must have at least one man and one woman? And then how many committees are possible with exactly 2 women and 1 man? How many committees are possible with all men? And how many ways are there to form a 3-person committee with president, vice president, and treasurer? So maybe those sound like maybe a bit overwhelming, but there's just two sort of simple properties that we can take advantage of here. So in general, if we have n total people or items and are choosing r of them, and the order does not matter, there are n. If you're using a calculator, you can do n NCR r. Or n choose r in Google. So we can use here. And if the order matters, we use NPR. If there's a button on the calculator we can use for that. So we can just use the calculator. We don't need to, there's a formula you can use with factorials, but we'll go into that in another video if you want to know how to do that. But so for these questions, how many ways are there to choose an executive committee? Well, it doesn't say anything about the men and women. We're just picking 3 out of the total. So we've got 12 total, and we're picking 3 of those. So we're doing, there's 12 total, and we're choosing 3. And does the order matter? It doesn't say anything about that. We're just picking 3. Order doesn't matter. So that's 12 choose 3, or 12 NCR 3. We can actually pop right into Google. So we're taking 12 choose 3. So it's reloading. 12 choose 3, and that's 220. So you can literally just use Google, or if you've got a calculator, so that's 220. If you've got a calculator, you can just use that. So how about, let's just 12 choose 3. So let's circle that to make sure it's clear. To do that in red. So B, how many ways are there to choose a committee if it has at least 1 man and 1 woman? At least 1 woman. So that's really 2 possibilities. We could either have 2 men, 1 woman, or 1 man, 2 women. We should look at each case here. So if there's 2 men, 1 woman, that's the same as, well, if we're picking 2 men from the 7 men, the order doesn't matter. So we're picking from the 7 men, picking 2, and then from the 5 women, we're picking 1. So we do 7 NCR2 times 5 NCR1. We can calculate the exact number again in Google. So that's give me a nice 105. So equals 105, and then 1 man and sorry, 1 man and 2 women. So we're taking from the 7 men, choosing 1 man, and from the 5 women, choosing 2. That's, we'll use the Google terminology, and that gets 70. So because we're picking from the 7 men, 1 of them, and then from the 5 women, 2 of them. So for C, how many committees are possible with exactly 2 women and 1 man? So 2 women, that's, and then, sorry, for D, we need to add these together, because those are 2 separate cases. So we combine to get, it's that 175. And then for C, the committees with exactly 2 women and 1 man, we already calculated that, that's 70. Calculating that in B. How many committees are possible with all men? Well, that's, let's see, we're taking a 3-member committee, picking those from 7 total. So it's just the same as we can do 7 NCR3 and put that into Google. Again, we need to change NCR to choose from Google. NCR will work on the calculator. That's 35. And how many ways are there to form a 3-person committee where the order does matter? So, like, this is president, vice president, and treasurer. So, well, there's a couple ways we can do this. We could use NPR. So we can literally, we're doing a 3-person committee, so we're taking the 12 and then doing NPR 3. So the order does matter. You can use that in your calculator. Google doesn't have, I don't know, it doesn't have an easy way to compute that. But another way to think of that is we're taking the total number of ways to choose an executive committee, so that's 220 from A, and then multiplying by the number of ways to rearrange the 3 people, so that's times 3 factorial. So there's 220 ways to pick 3 people for the committee, and then we can rearrange those in 3 times 2 times 1 way. So that's 220 times 3 factorial, or 220 times 6, and that's 1320. So great, that's it. If you have any questions about that, let me know. Otherwise, hope you have a great day.